Welcome to Alphanumeric Tricks. In this lecture, we are going to see Introduction to Differential Calculus. What is calculus? Calculus is all about continuous changes, and that is, calculus is the study of the branch of mathematics which deals with change and growth. That is, calculus gives the different ways or methods to calculate or measure the change and growth. For example, suppose you are traveling by a car and want to calculate the speed of the car. We can't directly calculate the speed of the car. In that case, you have to consider many things. That is, when the road is free, then you can raise up the speed of the car, and also due to traffic you can slow down the car, and also due to signals also you can slow down the car. All the things you should keep it in mind to calculate the speed of the car in a particular time period. So using algebra alone, it is not possible to calculate this. We can here calculus plays a very important role to get the correct answer. Here with with the help of the related by a function, with the help of the function, that terms are related by a function, and we can understand the changes between the values very easily. This is the main role about the calculus. In calculus we have two types. One is differential calculus and another one is integral calculus. What is differential calculus? Cutting something, that is, for example, cut a ball into small pieces and find out how it changes. That is your differential calculus. And integral calculus is join the small pieces and make a one ball and find out how much there is. That is your integral calculus. That is, generally speaking, cutting small things and find out what happened. That is your differential calculus. Join small pieces and find out what happened. That is your integral calculus. Now, mathematically speaking, differential calculus is based on rate of changes or slopes. And what about the integral calculus? Integral calculus is based on adding the effects of lots of small changes. That is your integral calculus. We can interpret these two parts of the calculus this way. One is that is geometrical representation and a physical representation. We can do that. Geometrical representation of a differential calculus is a slope of curves. That is, using tangent line we can find out the slope of the curve. That is the geometrical representation of differential calculus. What is physical representation of differential calculus? It is all about velocities. Finding velocities is the physical representation of differential calculus. In the same way, a geometrical representation of integral calculus is area under this curve. We are finding area under this curve. This is the geometrical representation of integral calculus. And physical representation of integral calculus is net changes we have to consider. Now we will see what is a differential calculus. Differential calculus we define in two ways. One is finding the slope of the tangent to the graph of a line. That is one definition. And another way of defining differential calculus is about finding the rate of change of one quantity with respect to the another quantity. That is the differential calculus. Now we will see some basic definitions like a slope, tangent and rate of change, and then again we come to this definition and conclude this. Okay, first we will see what is a slope. For this, consider this figure. X-axis, y-axis is there, and you have to find out the slope of this line. For that, you consider the change in x, and which is denoted by delta x, and you have to consider the change in y, and that is denoted by delta y. So the slope of this line is equal to change in y by change in x, which is delta y by delta x, which is the slope of this line. And also this ratio delta y by delta x is true for everywhere on this line, but it is not true for this curve. That is, why it is not true is, suppose you are finding this ratio here, delta y by delta x here in this, and suppose you are finding delta y by delta x here, or you are finding delta y by delta x here, or you are finding delta y by delta x here. It is not same, or it is not true, because it changes, it increases or decreases, the value will changes. So how you can find out the slope of the curve then? For that, you can find out the slope of the curve at only one point at a time. You can find out the slope at only one point at a time. Here the tangent line plays a very important role. What is tangent? Tangent line is when you draw a line and which touches the curve at a particular single point, that is called a tangent line. So using this tangent line, we can find out the slope of the curve. So tangent to the curve at that particular point is the slope. Okay, we can find out the tangent line, and tangent to the curve at a particular point is called the slope. This way we can find out the slope of the curve. And we can see that differential calculus gives us the tools to find the slope of the tangent line, that we will see in upcoming videos. Now we will see what is a rate of change. A rate of change is percentage of change in the value over a defined period of time. That is what percentage the value will changes in the particular period. That is the rate of change. And now consider this example. Suppose you are traveling by a car and want to calculate average speed of a car at a particular time period. I already told you to find, we have to to find out the average speed of the car. We have to find out the we have to keep it in with number of things you have to keep it in mind. The speed is distance by time. You can find it out. To find average speed, we have to keep it in mind number of things. So many things you have to consider. That is, when the road is free, you can definitely raise the speed of the car. Okay, and if the traffic is there, you slow down the car, and due to signals also you can slow down the car, and you can stop the car sometimes for some other reasons. So all the things you have to consider to calculate the average speed of the car, and considering this, using this formula, average speed is equal to change in distance by change in time, you can find out the average speed of the car. Now we can say that speed is about rate of change and slope is also about rate of changes. So speed and slope are rate of changes, and differential calculus deals with this rate of change. Okay, differential calculus deals with this rate of change. So we can conclude that the differential calculus is about finding the rate of change of one quantity with respect to the another quantity. Now we will see some other basic definitions. For this, we consider the circle x squared plus y squared is equal to r squared. Here x and y are called variables and the radius r is constant. What is the difference between variable and the constant? Why we say that x and y are variable and r is constant? Because x and y are the variables are the quantity which may assume unlimited number of values, and constant is the quantity whose values is unchanged. That is why we call it x and y are variable, and how you can say that it takes unlimited number of values in this circle. That is, the coordinate x and y moves, then you can get different values for x and y. Okay, it is true, isn't it? Yes. So when the coordinate x and y moves, you can get different values for x and y. But for this circle, the radius r is fixed, or constant. Radius r is the same radius only. We are finding the different circles at different points in a different circles. Okay, that's why x and y are variables and r is constant. This is the difference between variable and the constant. Now we will see what is a function. This is defined by using this set. Consider the set D and the set E, and here in the set in the set D we have number of elements are there, and in the set E also we have number of elements. And with this function, or with the help of this function or rule, using some rule or condition, each element in the set D is mapped into exactly one element in the set E, then we can get the function. So a function is a rule that assigns each element in the set D to exactly one element in the set E. That is the function. So a function is mainly, it is a rule or condition. Okay, using this only we can map the elements in D to elements in E. Exactly one element in the set E, that you should remember. Here D and E are set of real numbers, and D is the domain of the function. This D is called the domain of the full set is called the domain. Okay, here in the elements in this set is called a domain. And how will you define a range then? What is the range? How will you find out range? Range of the function is that is set of all possible values of f of x. Here set of all possible values of f of x when x changes, that is the range. In this domain, when x changes, we can get the possible values of f of x are considered as the range of this function f. Now we will see what is independent variable. Independent variable is to represent an arbitrary number in the domain. We are considering one symbol. That symbol is called independent variable, that is representing any arbitrary number in the domain. We using some symbol that is known as independent variable. Then what is dependent variable? Dependent variable is to represent a number in the range of the function, to represent the number in the range, okay, in f of x. And to represent a number in f of x, we are using some rule or some symbol that is known as dependent variable. We will see that with the help of this example very easily, or easy manner. Consider this function x plus y is equal to x squared. Here y is equal to, when you taking x to this side, you have x squared minus x. Y is x squared minus x, or you can write y is equal to f of x. We already know this. Y is always equal to f of x, which is equal to x squared minus x. Suppose you are giving x is equal to 1 here, then y is equal to x squared is 1 squared minus 1. 1 minus 1 is 0. That is f of 1 value is equal to 0. When x is equal to 2, y is equal to 2 squared is 4. 4 minus 2 is 2, or f of 2 is equal to 2. And in the same way, when you are substituting x is equal to 3 here, y is equal to 3 squared is 9. 9 minus 3 is 6. So y is equal to 6. When x is equal to 3, y or f of 3 is equal to 6. This can we will represent this in a set using setter function. Okay, we represent this in a function. Consider the set D and the set E, and this function assign the rule or condition is equal to x squared minus x. This f takes x squared minus x. Depending upon this condition or rule only, each element in the set D is mapped into element in the set E. So for example, here we plot this. When x is equal to 1 is mapped into the set E, y is equal to 0. Using this rule or condition, x squared minus x. In the same way, the element x is equal to D in the set D is mapped into the element y is equal to 2 in the set E with the help of the function f is equal to x squared minus x. In the same way, x is equal to 3 is mapped into y is equal to 6 in the set E. Okay, so here x is called independent variable and y is called dependent variable, and independent variable is in the domain and dependent variable is in the range. Okay, so here we can say that to represent any number in the domain, we are using the symbol x, which is called independent variable, and in the same way in the range, to represent any number in this to represent the number in this range, we are using the symbol y, that is called a dependent variable. So in an easy way, we can say that your depending upon the value of x, the value of y will vary. That is, y purely depends on the value of x. That's why y is called dependent variable and x is called independent variable. That's all for this video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. Keep watching our YouTube channel Alpha Numeric Tricks for more videos. Thank you.